Okay. So, hello everyone. Let's wait for everybody to join. We have 15 participants as of now. This meeting will be recorded, so I am just gonna, I will send everything at the end of this workshop, so don't worry, guys. And let's start introducing each other. Let's say hi in the chat. Let me know if you guys can use that. Just say where you're joining from today before I introduce the agenda for today and before I introduce our speaker who's already here. Hi, Akshat. Thank you for,
Very nice to see everybody.
yeah, thank you for joining. Where are you joining us from, Akshat?
I'm right now.
What is it?
Hello, am I audible? Sorry,
Yeah.
I said I'm in New York right now.
Nice, nice. New York must be cold. I see someone from Portugal. Oh, somebody else is from New York. Nice. I am currently in Berkeley, guys. Super excited for today's workshop. Idaho, awesome. Another question I had for you guys. This was an interesting workshop because I think it got filled up immediately. We had almost full reservation within one day. So I'm curious, what are you trying to learn today? What are you trying to get out of today's workshop? Share in the chat as well. What is your goal currently? I am really curious to know because I was sharing with Akshay the other day. I thought like everybody already knows how RAG works, but honestly, there's so much to learn under the surface. So we're gonna show that in a practical application today, and Akshay is gonna share his industry knowledge on building rack systems for customer support because he had experience with HP and Tesla, and that's why he's here to share all his knowledge. Also, Akshay has a mentorship program, I think, on TopMate. You are free to follow him on LinkedIn, and you will find his TopMate link over there. I will share his LinkedIn. By the way, guys, share what made you join today. What are you trying to learn today? And are you currently an AI engineer? Are you currently maybe an analyst who wants to learn about AI? I want to know why you guys are here. And meanwhile, I will share Akshit's page. This is uh, Tester Learning AI, Deepak. Nice. Here's Akshit's LinkedIn. Great. Data analyst wanting to learn more about AI. I love that. I love that. We have lots of analysts in our community, so I always love to see people upskilling with uh, current in-demand skills. Jyoti is saying she's helping. I'm an AI assistant. Oh, okay, that's that's an AI assistant, my bad. Okay, so before we get into the today's workshop, I had to share this story, and I'm curious if it resonates with you because that was the reason why we started Break Into Data community. So last year, when I was trying to learn by myself about RAG and all these design patterns that involved AI, including agentic framework and everything, I was sort of doing it on a passive way. I was watching online courses on YouTube, on DataCamp, and I realized whenever I tried to implement something with a real use case scenario, I would always get stuck and I couldn't unblock myself just because I was learning it passively by myself in my own room. And that's when I realized, why don't I just like do these peer programming events with Break Into Data people? And that's what we started doing. And on one of the events, something really hit me that's when everything like changed. I realized, Oh my gosh, when I shared my problem with the community, somebody like shared a better prompting strategy, somebody shared a better chunking size, somebody else pointed out for a better boilerplate or for some interesting GitHub repo that I didn't know. And that's when I realized the power of community, the power of learning together and applying skills in the real time. And since then, we've been hosting these applied workshops, hands-on workshops, and that's why we started Break Into Data Pro community. So I wanted to ask you guys about your experience as well. How are you finding learning about AI? And also, we are building something interesting for AI engineers, upskilling AI engineers. It seemed like when I was talking with people like yourself who are trying to learn about AI engineering, they think that it will take like 6, 12 months to learn everything, but in reality, it can be so much faster. And the things that you can build with it right now can actually change your career if you know how to talk about it, if you know how to build it for real use case scenarios. And that's why we're building an AI engineering program that will be launched in a month. And if you're interested in something like this, I would love to hear from you on the Break Into Data Circle platform that you guys came from. Just send me a DM asking or like telling me what it is that you want to learn, and we'll try to incorporate that in the upcoming program. But so far, I see lots of analysts, finance analysts interested, curious learning about RAG LLM. Graduate student, I love graduate students. We have so many of them. In fact, Akshat is actually also a graduate student who's recently graduated. Congratulations. And yeah, so
Thank you.
without further ado, please check your emails. We sent out the notebook that you can upload to Kaggle. Hopefully, you guys have a Kaggle account. Upload it there, and you can follow Akshat today and fill in the blanks, fill in the function blanks that you will see. And yeah, I think that's all. Let me know if you guys were able to find it. If not, ask it in the chat. I'll try to share it there. And yeah, I'm gonna pass it along to Akshit.
Yeah, awesome. So, good morning, good afternoon, good evening, depending upon wherever you're joining from. I'm excited to get started. As Mary mentioned, I'm Akshat Bhalla. I just graduated from Columbia University with a master's degree in data science. Prior to starting my master's degree, I worked for a few years as a data scientist at HP, where I used to work with what you can call as the customer support team. So when customers contact HP, it generates data, primarily in the form of text or in other formats such as tables. And from the point of contact until resolution, there is an entire business process behind the hood. When you call HP, you know there's something going on in the background, right? Or when you call any other company, there's something going on in the background. That whole customer support process is an important one for the company. It brings in revenue, it helps cut costs, etc. Right? So one application of NLP these days is RAG. So today we'll be discussing how we can integrate RAG into customer support pipelines. This is not something that I was doing actively at work because these technologies emerged only recently. But I'm pretty sure if I was working, let's say at Amazon today or at, another company today where, I was working with a customer support team, these are the sort of things that I would do to build a RAG pipeline. So I'm excited and let's get started. If you guys are new to Kaggle, then I would advise you to create an account right now. Maybe I can share my screen and we can get started. Let me share my screen. All right, let me know when my screen is visible. Yeah, I hope my screen is visible. So yeah, I'm on LinkedIn. You can follow me here. We can connect, and if you want to talk to me, then there's also my TopMate link here. If you find that there are not enough slots, then you can always message me on LinkedIn, and then I can create some slots for you. So that said, let's get started with the Kaggle notebook. I hope this notebook has been shared with everybody in this workshop, Mary. It has. All
Yeah,
right, great.
so I shared it in the chat. Let me know if you guys can access it.
So let me give you guys about 2 minutes to set up your Kaggle account. So what you have to do is go to kaggle.com, right? I already have an account, but let's say I did not. If I created one, then this is the sort of page that you should expect to see. You should see, a blank icon on the top right. You shouldn't see any progress here, but this is the sort of page that you're supposed to see. Then on the left side, just go to code, create a notebook, and you should be on this page, right? And you can just upload a notebook here, file, import notebook, and upload my notebook. When you upload my notebook, we should be on this page and we should be together. So if you guys would like to, then I can go over it again so that we can all be on the same page. I'll give it just another minute. It's real quick. Okay, let me go over it again. Let me actually log out maybe and then I'll show you guys. So if you go to kaggle.com, you can register. You can register with Google and you can select your favorite email ID here. I'm going to select, my existing account. And when I do, I should land on the page that I had shown earlier. Since I'm already registered with Kaggle, I'm just going to sign in with Google. And yeah, so this is my Kaggle account. When you're on Kaggle, you can navigate to the code section on the left. So if you press code, you land on this page. Let me just stop here for a while and let's see if you guys are on the same page with me. Kaggle would be faster because it has pre-downloaded libraries. Yeah, it does. Can we use Google Colab as well? I think you might be able to use Google Colab, although I did not test it on platforms other than Kaggle. Kaggle has most prerequisites installed for you. So it's going to be pretty smooth on Kaggle. I cannot say the same for other platforms. Okay, looking forward to hearing about RAGs at Tesla. So I think I forgot to mention the prior to, after starting my master's degree, I was also doing an internship, which was at Tesla, where I was a data scientist. There I got to explore elements of GenAI, etc. So we can maybe take up questions after the workshop.
Yeah, sounds good. Also, Akshit, can people ask relevant questions to like a current, whatever you're covering currently, like make it a little more interactive?
Yeah, we can do that. Sure.
Awesome. Yes, and the general questions could be left for Q&A towards the end, guys.
Yeah. Okay, I'm assuming everybody's on this page right now. Can people respond on chat and let me know if I can get started? Done with the setup. Ready to start. Sure, yes, ready. All right, perfect. So when you're on this page, if you click on new notebook, you will land on a page that looks like this, right? So when you're on this page, on the top left, under, you see this notebook and some numbers. Under that, you see file. In the file section, just choose import notebook and import my notebook. Import the notebook that has been shared with you by Mary, and we can get started. Okay, when you guys import that notebook, this is what you should see. Although the notebook name might be different, it might still be something random, notebook XYZ something, but you should see this code in your notebook. If you guys are here, let me know in the chat and we can get started. All right, great. Then let's get started in the interest of time. So, um, on the right side here, you will need to select accelerator as GPU. You can either select T4 cross 2 or GPU P100. Anything works. I've selected the first one. Once you do that, you can, again, let's minimize this and you can start your session. Okay. After you start your session, just execute the first cell here. I'm doing Shift Enter to execute it. You can also use the same command. This will take a while to run, and while it does, I will discuss the overview of RAG with you. All right. So let's talk about RAGs. When you interact with a large language model, okay, just before we start with RAGs, if you have successfully started your session, on the top right, you should see the option for GPUs. If you see this GPU option on the top right, that means you've done everything right. We're on the same track. We're on the right track. And after executing the cell, you should see, content like this on your screen, which means the required dependencies are being installed. All right. Now let's talk about RAGs. But before we talk about RAGs, we have to understand what large language models are. And before large language models, there were language models. So let's go over that quickly. So what is a language model? Basically, any mechanism that generates text with some probabilities is called a language model. So it could accept text as input, it could accept image as input, it could accept a whole array of other things as input, but the output should be text. And this text must be produced with some probabilities. Then it is called a language model. These days, the mechanisms for creating a language model involve a lot of parameters. They're huge. The mechanisms themselves constitute a lot of space even on your disk, which is why these language models these days are called large language models because they have so many parameters to work with internally. Now, a large language model learns a representation for the entire world. If you've worked with ChatGPT, you would know what I'm talking about. When you talk to ChatGPT, you input text and it responds with text. You could ask questions about anything and it has learned knowledge from the entire world, so it is able to answer any questions you may ask it, right? But it still fails to answer some questions accurately. For example, if you say, can you tell me about Akshat Bhalla? It will probably not give you the right answer because it does not know who Akshat Bhalla is. If, let's say, you are a data scientist at Amazon and you say, you want to know how to set up a customer account. So you ask, your language model, how can I set up a customer account? Now, your language model might give a generic response about how to set up an account, but it will not be specific to Amazon, right? So how do you ground your large language model responses to facts about the company, its people, its products and services? You can do that using a RAG. So a RAG is simply a mechanism to provide a language model with context, right? Context about products, services, etc. A whole host of things. So a RAG is simply a mechanism to provide a large language model with context. So let's see how that works. So in the first image you see, we pass a query to a large language model, which means just some text to a large language model, and the response that it provides is irrelevant. It's not relevant to Amazon and its businesses, right? So if you're a data scientist at Amazon, you expect to see a response that's relevant for Amazon, and it does not do that. So it's an irrelevant response. So how can we fix that? We can fix that with a RAG. So what we do is, one moment, I think my internet connection might be unstable. So if in case there are any disturbances, please do let me know. I'm constantly checking my chat to remain updated with the status of what's happening in the chat section. So please do let me know. Okay, coming back to RAGs. So with RAGs, what we do is we have the query that we want a response for. So we put that query in a vector database, and that vector database spits out context about, you know, that question. For example, if the question is about setting up an Amazon account, then that vector database will spit out documents related to that question, right? And we use those documents along with the original question, we concatenate both, and we create a new query that I'm calling augmented query. Now, that new augmented query, that new prompt, has not just the question, but also the context that we retrieved from a vector database. We put this new augmented query as input to a large language model, and that large language model now looks at not just the question, but also the context. And now it is able to spit out a relevant response, right? Now, you may be wondering what is a vector database? That is something we will be digging into today. So let's go over. So creating a vector database is all about creating a RAG pipeline. Truth be told, you do not even need a vector database, as you will see when I describe the RAG pipeline. But having a vector database is cool because as your data size grows, you need to store it somewhere. You can't always hold it in memory, or you can't always hold it on disk in your local machine or on your server. You need to store it somewhere. So with growing project needs, vector databases come in handy. So we will go over creating a vector database today. So let's look at how we create a vector database, which in other words is just developing a RAG pipeline. So let's say you're a data scientist at Amazon and you have a number of documents, which could be PDFs, PowerPoint presentations, Word documents, Excel, etc. Right? You have so many documents about the products, services, about the people, about the processes in the company. And to the best of your knowledge, these documents represent everything that there is to know about the company. Okay. Now, what we want to do is we want to extract all the text present in these documents. So the first step is gathering all the documents. The next step is extracting the text present in those documents. Now, we could also extract images, tables, etc. But that is not the topic of discussion for today. For today, we will only stick to text. So you have all these documents, you extract text from them. After you extract text from them, you want to, chunk those texts. For example, one text could be, you know, 10,000 characters long. You don't want such huge texts. You want to break it down into smaller pieces of texts. So you break down these texts into smaller chunks. So that process is called chunking. And each chunk is then embedded. So we develop some embedding for each chunk. And embedding is just an array of numbers that represent that chunk in a latent space, right? And then each embedding is stored into a database that we call a vector database. Since an array is also sometimes called a vector, this embedding that we are creating is essentially in mathematics called a vector. This database in which we store these vectors is called a vector database. So it's nothing new, it's nothing fancy, it is just a database that stores embeddings, nothing else. Technically, the way in which you store your embeddings should be such that you can, you know, extract information quickly. So your embedding should be arranged in such a way that, retrieval is easy. Retrieving information is easy. So the way in which these embeddings are arranged is also called an index. So creating a vector database is also called indexing. Ideally, like I said, you don't even need a vector database. So you could do this indexing with, a whole array of other methods as well, right? So that's about creating a RAG pipeline, and we will soon be jumping into the technical details. I know that I have been using some technical words such as, embeddings, latent space representation, etc. So this workshop would assume that you have some basic understanding of what, machine learning is about, how neural networks work, etc. Although we won't be training any new neural networks today, but having a good understanding of what's happening would be really helpful. Do we have any questions in the chat? Okay. All right. So yeah, let's get started. Is everybody on the same page? Does everybody have this on their screen? Does it look like this for everybody? Ideally, you should have some installations So let me go over that quickly. We are using a library called PyPDF2 to extract text from PDF documents. That is why we are making this installation. Then we have these two statements to, install some GPU dependencies. Next, we will be using Ollama package to um, download the large language model in your environment. So to do that, there is a nice hack I found at this link. So using these commands, Ollama gets installed in your Kaggle environment, and then you can start interacting with it. So the large language model we will be using today is called Llama 3, but RAGs are not hooked onto a particular LLM such as Llama 3. You can always change the large language model and use another one of your choice. You could use Mistral, or you could use ChatGPT or Sonnet or any other of your choice. So Llama 3 is only being used for example. So Llama 3 is the uh, generating model, the model that generates your output based on your input. But you also need a model to embed your chunks. And for that, we will be using this model that you see here, MXBAI embed large. And lastly, you will need to install Ollama so that you can use the Python API for it, as well as ChromaDB, which is the vector database we will be using today. So when you execute these commands, you should see all of these messages on your screen, all of these installations. So this is the first important installation. This means that your large language model, or Llama 3 to be specific, has been installed onto your local system. So as you see, it reached 100%. And the next installation is the embedding model that we saw. So once both of them are installed, you should see messages like these. And after it hits 100%, okay, that hit 100%. So this is the embedding model that is being installed. And let's see where it hit 100%. Yeah, it hit 100%, right? After that, it's installing ChromaDB and some other dependencies. So if you have all of these installations ready, then we can get started with the code. So let me quickly check the chat. Let me type it here. Shall we get started with coding? That's my question. If you're excited to get started, then please enter that in the chat and we can get started. Okay, I see one response. It would be helpful to have responses from everybody else. Yes, please, definitely. All right, perfect. So let's get started then. So if you execute this first cell, all the necessary libraries and packages will be imported. So as I mentioned, we are using ChromaDB for the vector database. We are using JSON because we will be interacting with the large language model using APIs. So JSON will be required. We are using Ollama, which is the package to download the large language model, query the large language model, etc. So Ollama is being used for that. Glob is simply to work with the PDFs. So I have imported Glob. PDF reader is being used to extract text present in PDFs. So that is why we're using PDF reader, and TQDM is just to track the progress of for loops, right? So let's say I have a question now. My question is, how do I manage my save addresses? Now, if you're a data scientist at Amazon, how do I manage my saved addresses means something very specific to you, right? It means something very specific to you. But if you ask this question to a large language model such as Llama 3 or ChatGPT, etc., you will get a very generic response. And let's see how that is. So I'm going to execute this query. I'm going to execute my query model. My query model is Llama 3. And I need to execute this function to retrieve a response for this question and this model, right? And once I write this function and execute, this cell, I should get a response. So let's quickly write code to get a response from the large language model, right? So I'm going to write some code, and I would like you guys to follow along. So I'm going to say my response is equal to Ollama, which is the package we are using to communicate with the large language model, ollama.chat, because we are chatting with the large language model. Enter. And I'm going to say my model is equal to my model, and my message, because we are interacting with the large language model in a chat format, we would need to pass a message, and I'll say message is equal to, and I need to pass the message, right? So I'm going to say role user, and I'm going to say content question. So when I do this, this is a way of telling Ollama that I want to chat with a model, and this is the model I want to chat with, and this is the message that I have for you. I'm the user who is interacting with the model, and the question that I have is being passed in this manner as the content, right? And so that my responses are the same as your responses, I'm going to set an option called seed. So I'm going to set seed. I'm going to say options is equal to seed 42, right? So if we use the same seed number 42, then your responses will be the same as mine as we observe on the screen. Okay. So I'm going to return this response now. Response, and I'm going to say message and content, right? Content. Okay. I would be happy to show you the raw response and show you why I selected message and content. But I think it would help for you to break it down on your own in your time, in your free time, and see what's exactly going on behind the hood. In the interest of time, I will keep moving one after the other as we fill in the to-dos here, as you see. It would help if you guys can, sit down and, try and understand what's happening behind the hood. So this workshop is all about creating a RAG from scratch, but there will be questions you have in your mind. If we have time by the end, we will take them up. You can always message me, later on if you have any questions. And it would help if you can, sit down and try it yourself so that you get a good understanding of what's going on. So now that we have this code, I'm going to execute this function, and I'm going to say response is equal to, oops, so we see some error. We see unexpected keyword argument message. I think this should be messages. So let's execute it now. Okay, I think that was right. So this is the code you guys are expected to enter. I will also be pasting this code in the chat so that you guys can use the same code in case you're lagging behind. Let me copy paste this onto the chat. Although I'm copy pasting it on the chat, it would really be great if you guys can type it yourself, because that will give you more confidence about what's happening in the background. Okay, let me paste it. All right. So let's see what response we got. So the question was, how do I manage my saved addresses? And we asked Llama 3 this question, and look at what response we got. Llama 3 says, managing your saved addresses, also known as address book or contact list, is an essential task to keep track of your frequent contacts, friends, etc. And it goes on to explain, and it says some popular clients, blah blah blah, are Gmail, Outlook, Apple, Google, etc., etc. So it did not give an answer specific to Amazon at all, right? Which is a problem. When you work as a data scientist at Amazon, you need your chatbot to give you responses relevant to the company. So how do we do that? For that, we need to create the RAG, right? So before we create a RAG, let's look at our data set that we will be using today. So on the left, on the right side, if you see this bar here, you can expand it. You will need to add this data set called customer support data, right? So you can click on this button, add input, and you can say customer support data. Let me maybe share. I have created, access this and work with it. So let me first share this in the chat. I'm pasting the link in the chat, link to this data set. So all you have to do is you can copy paste that link here that I pasted in the chat. If you paste it here, then this data set will show up. You just have to select the plus button here on the bottom right to add that data set to your environment. When you do that, this data set will get added to your environment and we can start using this data set right away. So let me know when you guys are able to do that. I'm going to go over the data set to give you a glimpse of what real world data sets can look like for this kind of a problem. Let me know if you guys are able to access the data set so that we can, continue and we can all be on the same page. So about this data set was created by me to demonstrate real world data in the customer support domain. There are three files that I created. So this is a synthetic data set. It does not really belong to any company. So there is no PII as such. It was created synthetically. So there are three files that I created. The first file is FAQs, which is frequently asked questions. The second document is howtoguides.pdf. And the third document is productinformation.pdf, right? And each of these PDFs have some, relevant information in them. The FAQs has 60 frequently asked questions about, questions and their respective answers. The how-to guides has 20 examples for various requirements, and the product information has around 50 products and their information, right? So let's look at what these documents can look like. It's a really small document, isn't it? So this, if I see correctly, this is FAQs.pdf that is being displayed here. It has information about account management. 1 to 15 means the first 15 questions are about account management. The first question is, how do I create an Amazon account? And there is the answer. Click sign up, etc. The next question is, how do I change my email address? Go to account settings, login and security, and update, and so on and so forth. So you will see all of these FAQs listed in this document. And there must be around 60 FAQs, right? And these FAQs are obviously company specific, which is great, which is what we want. The second data set, oops, where do I find? Yeah, the second data set is how-to guides. In the how-to guides, there are different sections such as customer service automation. The first part in that is how, I'm sorry, but I think somebody's audio is, or the mic is on and there is a little bit of disturbance. I request the participants to keep their audio off so that there isn't any noise. Okay, perfect. So yeah, so this dataset, howtoguides.pdf, has, questions about how you want to do some things and, the steps. For example, there is how to cancel an order that's already shipped. And, there is a stepwise guide for how to do that. In the real world, companies have such documents, right? So this is an example for, a how-to guide. Then lastly, there is product information. You can imagine the kind of product information that Amazon has access to, right? There are thousands and thousands of products, and chances are there is a catalog for such information where you can find the brand, the price, the description, the rating, the reviews, etc. Right? So here is an example for a product information. The first product is wireless noise cancelling headphone. And then there is brand information, category, price, description, key features, etc. Then there is a smart home security camera and so on and so forth, right? So these are three data sets that we will be working with. Right now they are in PDF and we would like to extract that text. So let's get started. Um, I hope you guys were able to copy paste the link to the data set that I have shared on the right side here. So on the right side, on the bottom right, there is this option. that you can click this little arrow, if you can see on my screen. When I click that, I have the option to add input. And in the add input section, I see this place where we can search data sets. So you can search for my data set by pasting the link. Once you have my data set pasted here, you can just add it using this plus icon on the bottom right, right? When you do that, it should get added to your environment and we can now start working with it. Let me quickly uh, ask in chat if you guys were able to do it. So shall we code now is my question. Please let me know if we can continue coding or you guys are having issues. All right, so I see a lot of positive responses in the chat. Okay, in the interest of time, we will get started. So as you see, we have installed this data set in our environment. Now we can use it. So first we will read the PDFs. So let's see how to do that. Oops, give me one moment. So let's see how to do that. So we have this read PDF function, right? We will want to fill that in. So I'm going to say reader is equal to capital P DF, capital R reader, in brackets, file path. So this will create a reader object to read this PDF specified in this path. Okay. And once we have that reader object, we will have access to the PDF. But as you saw, PDFs can have a number of pages. So we will have to iteratively go over each page and extract text. So we have page 1, we extract the text. We have page 2, we extract the text. Page 3, extract text. And each time we extract this text, we have to concatenate it so that we have all the text extracted across all PDF pages in one object, right? So let's do that. We will create a text object. Initially, it's an empty string. Then we will say for page in reader dot pages, and we will say text plus equals to page dot extract underscore text, right? This will extract the text present in all PDF page, in all pages present in the PDF that we pass, right? And we can just return the text. So let me run this cell and also run the next cell. So when we do that, it was able to read, this, I think this is the how-to guide, or this is the FAQ, right? So I passed the FAQ here as input to this function, and it returned all the text present in that PDF document, right? As you can see, it is huge. I think there should be all 60 FAQ questions. Yeah, you can see at the bottom, there are 60 FAQ questions. So it was able to extract the text present in all of those PDF pages. Now I'm going to paste this code in the chat for you guys to refer to it. So I've pasted it in the chat so that you guys can copy paste it onto your notebooks in case you guys are not able to, get the right output. Um, Somebody says no such file or directory, Kaggle input customer support data FAQs. Malik has said that he gets this message where where the message says no such file or directory. Malik, I think your data set was not added to the environment, so Kaggle is not able to find it. Are others able to execute the cell successfully? PDF reader is not defined. So Bora says that PDF reader is not defined. I think initially when we were making the installations, running the first installation would install PDF reader. So you need to install this to get started. I think this wasn't installed, which is why you're seeing PDF reader not. It's PDF reader, not PDF reader. Hmm. Yeah, I think Siddhant has correctly pointed out that it is PDF reader where P is capital, DNF is lowercase, R is uppercase, and EADER is in lowercase. I think you should take care to, mention the case properly. Are others able to successfully execute this cell where we extract information present in the FAQ document? Let me know in the chat so that we can continue. We have around roughly 10-15 minutes left to successfully execute code across all cells, and then we can leave some time for questions. So please let me know. Yes, able to run. Awesome, Jyoti. Gangotri also says yes, she's able to run. Also, guys, if you're not able to run things successfully in this workshop, which can be a little heartbreaking, but at the end, we will share the completed notebook so that you can sit down and execute cells on your own and see how things work. Remember that if you're running this on Kaggle, which I highly recommend, then you must also have this data set, customer support data in your environment. Without this data set in the environment, Kaggle will not know which PDFs to read. So please keep that in mind. Okay, if I get a few more yeses, then I will continue writing more code. So let me know in the chat. So Siddhant says yes, Sakib says yes. Okay, then let's continue. Okay, so now that we have extracted text from our PDF, let's go back to the diagram. So we had documents, right? We have the second step, which is text extraction. We did that successfully. The third step is chunking. So the idea is that this text is huge. There are like 60 questions, and I don't even know how many characters this is. This is a lot of text, right? The idea is to chunk it. Chunk it simply means to break it down into smaller texts. So maybe this is my first chunk, right? Until here. And then maybe this is my second chunk until here. And then maybe this is my third chunk until here, and so on, right? Now, this is one way of chunking, right? Another way of chunking could be I take this text from here to here. This is my first chunk. And instead of taking my second chunk from here, I take my second chunk from here, right? Which means there is an overlap between two consecutive chunks. Why do we have that overlap? So that context is not lost. When we try to break text into smaller texts, what happens is at the point where we break the text, information can be split between two chunks. And we may not want that. Maybe we want to preserve information in both the chunks, right? So that is why overlapping is the method that we will be using today to chunk texts. There are so many more chunking methods available. In some tutorials and in some applications, I have seen that people use this text and give it to a large language model and ask it to summarize it. And they use that summary and then chunk that. That's like the longer way of doing things. I feel it's okay to just break down this text as it is into chunks, and that's what we will be doing today. So no extra step. We will create chunks using fixed lengths. We have a character length of 2000. So we will take 2000 characters. Maybe this is the 2000th character. So this will be the first chunk. We will take an overlap of 200. So maybe that overlap starts here. So this will be the next chunk until the 200th character. So this is how we will be coding today. Now you may be wondering, why did I select 2000 and why did I select 2000 for the length of the chunk and why did I select 200 for overlapping characters? Well, it was an arbitrary choice. And this is something that you will want to maybe explore by trial and error, what works best for your application. There's nothing really set in stone. It's all about creating a good RAG pipeline. If this does not work well for your RAG pipeline, then you must explore ways of improving it. And each element can have its own workshop. Like how can we improve, chunking, or how can we improve indexing? Each of these components can have their own workshops, separate workshops. So right now we will just go forward with one method, which is fixed length chunking with overlap. So let's look at the code for that. All right, so we have this function that we need to complete. So this function takes in text, which is the first parameter or argument, and the next two arguments are max characters and overlap. So as you can see, you can always adjust this. Instead of 2000, you could have easily taken 5000 or 1000. You can also change the overlapping characters. Maybe you don't want any overlap, in which case you can pass 0, and so on and so forth. Right? So let's write down this function. I'm going to erase the to do, and I'm going to say chunks is equal to an empty list. So I'm creating an empty list to, you know, uh, I'm creating an empty list to which I'll be adding all my chunks. And I'm going to say start is equal to 0 because we start at the 0th index of the text. Oops. Now I'm going to say while start less than len of text. Actually, it'll help if I can go over the logic that I'm using to create the chunks. So what I'm doing is I start with the 0th character, which is A, and then I look for 2000th character. So I keep looking character by character, character by character. And the moment I come across the 2000th character, I stop, right? So that is my first chunk, and I append that to my list. So now I know that, this question mark is the 2000th chunk, or I should say 1999th chunk, right? Because it's from 0 to 1999. So this is my 1999th chunk, sorry, 1999th character. And I'm going to take 200 characters before this particular index. So maybe that starts here, right? So I'm going to start my next chunk from this point. So from here until the 200th character, maybe that ends here. So I know that, the 2000th character ends here. So I'm going to select the 200th character before this, which is maybe here. And from here until the next 2000th character, then this becomes my next chunk. So this is how the algorithm works. I'm going to write code for it. And I'm also going to paste it in the chat like always. Because we are short on time, we will go over the next steps such as embedding and creating a vector DB quickly. Okay, so let's write code for this. While start less than length of the text, because we want to continue chunking until the end of the text, we will say end is equal to min start plus max scars, right? So this condition handles like an edge case, because by the end, let's say the 2000th character ended here, right? It ended here. The next chunk would maybe start from 200 positions before the end. So maybe that position is here. And if I consider everything from here until, the 2000th character, unfortunately, there is no 2000th character, right? Because my entire text ended. So either I have to take the 2000th character or the end of text, right? Which is approval and full stop, right? So I'll have to take the minimum of both, which is why I'm using this minimum of start plus max characters or the length of the text. And then I'm going to say chunks dot append. So I'm going to append the substring from start to end index, right? And I'm going to say, I'm going to update the start position. So I'm going to update my start position as start is equal to start plus 2000. So that start takes up, the nth 2000th position. And then I'm going to subtract the overlapping number, which is 200, so that I can have that overlapping text as well. And I'm going to return chunks here. So let's see how this code does. Yeah, so when I executed that, my function was able to create chunks. As you can see, this is the first chunk. Oops, maybe I should put this aside. Yeah, so as you can see, this is a list of chunks, and I think this is the first chunk that ended here, right? So the next chunk starts with EATURE. So EATURE to create a child. So I think this is the part where it started overlapping. So EATURE is actually feature. So EATURE, it starts here. So this is the overlapping part with the next text. As you can see, between the first chunk and the second chunk, there is an overlap. Uh, Checkout 17 how. So year checkout 17 how. So you see, this is the overlap between the first and the second chunk. So this is the second chunk, and this second chunk ends here. And then again, you will find an overlap here. Uh, Select GIF wrap, and then there is the select GIF wrap. So there is some overlapping here. So it created all the possible chunks that it could. Let me copy paste this code in the chat for your reference. Okay, all the code that I'm writing, it's actually quite simple. If you're giving coding interviews, then even before they ask you anything about RAG or about machine learning, deep learning, before they ask you anything like that, they will tend to ask you DSA questions, lead code style questions. And all of the stuff that we are writing right now is actually a DSA style question. If you are given this condition where you have this text and you have to create chunks of this text, such that there is an overlap between two chunks. How would you do it? This could be an interview question for you, right? So this is how lead code and DSA actually integrates with, data science, machine learning, etc. Most of the times in the real world, if you have to create a RAG, chances are you will just use a library, right? You will not do all of this. All of this will be behind the hood being done by the library for you. But it is always good to know what's happening behind the hood. If you're a good data scientist, if you want to make it big in this field, you should know how everything works from ground up. You should know how to create RAGs from scratch, even in the absence of a library. What if you have to create the library for the company, right? So it's always good to know coding in this way. Okay, so that's about that. I hope you guys are able to get the the chunks just the way I did. If you guys could confirm on the chat, that would be great. Do you guys get chunks? It's almost 4, so I will quickly go over the remaining steps without wasting much time. If you guys could confirm on the chat, that would be great. Okay, I see a thumbs up by Kush. Sakib says yes. Jyoti also says yes. Okay, then let me get started with the next part of code, which is generate embeddings. So now that we have these chunks, we have a list of chunks. We would like to create embeddings for each chunk. Now, how do we do that? Now let's write code to do that. So we are writing a function that takes in the chunk, which is the text, and the embedding model of our choice, whatever model we want to use to embed those chunks. So we will be using this model as we discussed earlier. MXBAI embed large. So let's see how we can use Ollama to create embeddings. So we will say response is equal to Ollama. This syntax must be familiar to you because we already wrote code that looks very similar to this. And then we write prompt is equal to chunk. So we say, again, as before, oops, options seed 42. Okay, great. So what this code does is we say, hey, Ollama, I want you to create embeddings using this model. So here is the chunk for which you need to create an embedding. And we are going to use, so we are going to use options with seed 42 so that whatever you see on my screen is the same thing that you see on your screen. For seed is a way of, maintaining reproducible code. So With this, let's return response embedding. Okay, great. Embedding model. Oops, I forgot to run this line. Okay, so we now have these nice little embeddings. Um, Let me minimize this. Yeah, we have these nice embeddings now. I passed the first chunk. So I say chunk of 0, which is the first chunk, and then I called this function and I said, hey, use this chunk, use the embedding model that I defined on the top, and print the embedding. So it took that embedding, it took the very first embedding. This is the chunk that it took, the first chunk. This is where it ends. This is the first chunk, and it created an embedding for it. And I'm not even sure how long this embedding is. I think it should be 1024 numbers if I'm not wrong. So it's a huge list, right? So this is an embedding for the entire text. All right. I will not go into what really an embedding is. This workshop would assume some knowledge and background about such content. So I will move on. Let me first copy paste this code on the chat. Let me know if this code works for you. If it does, I would be happy to continue. After this, I will be discussing indexing with vector database. Essentially, we create these embeddings, right? We would create these embeddings for all chunks across all PDFs. And now that we have all of these embeddings, what do we do with them, right? We store these embeddings in a vector database. So so the vector database essentially stores text and its embedding, text and its embedding, text and its embedding. When the vector database has all of this information, in the future, when let's say I have a query, like, we started off with this question, right? We started off with the question, how do I manage my saved address? In the future, when we have this query, we will use the same embedding model to embed this query, right? And when we have an embedding for this query, we will give it to the vector database and say, hey, you know what are the similar embeddings you can find for this uh, embedding? So we have embeddings for this query, and we have embeddings for all the chunks in our vector database. And the vector database will look for cosine similarity between the query embedding as well as the chunk embedding. It'll do that for every chunk, and it'll say, hey, you know what? Um, the most similarity between the two embeddings is between so and so chunks, and those chunks are most relevant to your question. So those relevant chunks are the chunks that we will use as context for the large language model. Um, okay. So as the next step, we want to, store all our information into the vector database. I had a few to-dos here, but given that we are short on time, we can easily skip those. Those are not required. The important thing here is that we, initialize the vector database in the first place, which is why we will need to execute this line of code here. But before that, let me check if you guys got the results as intended. Did you guys get the results? So on the chat, I'm asking you guys if you got the results. So please do let me know if you have the results. So interacting with a database, be it a vector database or any other, is really simple. You should know the CRUD operations, creating a record, reading a record, updating a record, and deleting a record. These to-dos were essentially meant for that. Here I was going to demonstrate how to insert a record, how to view a record, how to delete a record. And after deletion, we view that, that record is gone. But now that we are short on time, we can easily skip this. But the completed notebook that we will be sharing with you guys, that will have code to do all of these things. So don't worry about it. Let me know if you guys were able to get results, if you guys were able to see this embedding. Please do let me know in the chat so that we can continue. Okay, Siddhant says yes. How about others? Are you able to get the embedding? I would like to know how others are doing in the chat so that I have a good sense of how others are doing. Bora, I keep having to reinstall all packages for some reason. Um, Not sure why that might be happening, Bora. Usually, you need to install packages only once. If it helps, then, with all the code that you have already in your notebook, you can just maybe on the top right, if you can, so this is not for everybody, this is only for Bora. If you're having issues, then maybe you can close this tab and, um, open the tab again and maybe run the code again one by one. It'll take some time, but at least you will get the results that you want to see. So you're saying the PDF reader in particular. So Michael says the data set is there, but the code can't recognize it. Not sure why that might be happening. So you say file not found. This might be some configuration error. Not sure why you guys are not able to find the data set. Were others able to follow along and access this data set? I guess so, because the others were able to get the embeddings. I'm sorry that you guys were not able to get the results as you were expecting. You were not able to access the data set or you were having to reinstall packages. We will be sharing the completed notebook after the session. And my recommendation for you guys would be to, use Kaggle, turn on the GPU and install this data set. The link was shared in the comments. And yeah, if you just run all cells after installing the, after, having the right notebook, you should see the results. Okay, there are others who are facing challenges with PyPDF too. Okay, I see. Okay, while it may not be possible to look into these errors one by one for you guys, I would recommend maybe we can continue with the workshop and see, the rest of the flow of code. And with the completed notebook, you guys can study what's going on. That might be more useful. So let's continue. I'm going to execute this cell. So this creates an object called client for the database, which is ChromaDB in our case. And using that client object, I need to create something that's called a collection of documents. So I'm going to create another object called collection. Collection is like a list. So this list will have, all the records that I want to insert into the vector database. So record could be, a row with ID, with chunk and the embedding respectively, right? So having executed this line of code, let's go to, until this point, we have actually done everything that we needed to do. There is no more code writing anymore. Once we have initialized this database, we need to put everything together. What we need to do is we need to use Glob to access all our PDFs, right? So all our PDFs, because I gave Glob this path and I said star.pdf. Star.pdf means everything in this, all the PDFs present in this path, right? All files in this path that end with the extension .pdf. So Glob retrieves all such um, uh, paths. So this is the first path, which is the FAQs.pdf file. This is the second path, which is the howtoguides.pdf file. And this is the third path, which is productinformation.pdf file, right? So it retrieved all these three paths. I'm going to enumerate over these paths. I'm going to iterate over these paths one by one. And each PDF will have multiple pages, right? So each time I enumerate over one PDF, I read it, right? I read it, I extract text from it. After extracting chunk from that PDF, after extracting text from that PDF, I chunk those texts. So I call the chunking function. And once I have a list of chunks for the PDF, I embed those chunks. And this is the for loop for iterating over the chunks, generating those embeddings. And once I have an embedding, I'm going to immediately add it to my vector database. So I'm going to say collection.add, and I'm going to add a row with 3 columns. The first column will have IDs. So I'm going to, I'm creating IDs here. And then the second column is embeddings. So I'm going to pass the embeddings here. And the third column is chunk. So I just inserted or added a row to this vector database to, insert the required information. So let me execute this cell. So this was pretty fast. It went over the 3 documents in 3 iterations very quickly. It hardly took a second. But in the real world, if you have a lot of documents, like sizable documents, then your vector database can take maybe minutes to hours to create. So we have our vector database created. We've inserted all our chunks to this vector DB. Now let's see what we can do. Now now that we have our vector database, we want to query that vector database to retrieve all information that is relevant to the question that I'm asking. So initially we started off with this question, right? How do I manage my saved addresses? How do I manage my saved addresses? So I'm going to go to my vector database and say, hey, you know what? I have this question. I want you to give me all relevant information for my question. And the vector database will return relevant chunks. So how many relevant chunks do you want the vector database to return? So I'm going to say k is equal to 3. K is equal to 3 means return 3 relevant chunks. Return 3 chunks that are related to the question that is being asked. So in the background, what is really happening is KNN search, K nearest neighbor search. If you know machine learning, you know what K nearest neighbor is. Basically, if you have the query embedding and you have all the chunk embeddings, you want to find three neighbors of the query embedding. So that is what K nearest neighbor search is for. It is a very general problem in not just machine learning, but computer science in general. So I'm going to execute this cell. And as you can see in this cell, what is happening is we say generate embedding for the query, which is the initial question that we asked. And I'm passing the embedding model. And this is the query embedding. Then I say k is equal to 3, which means I want 3 chunks relevant to the question I'm asking. And this is how we query the vector database. We say collection.query. We say query embeddings is equal to query embedding. So we pass the query embedding to the vector database, and we say end results is equal to how many ever results you want to fetch. So let's execute this chunk. This piece of code. So the results that we see here is in this format. We have IDs. So ID 00, ID 12, and ID 01 were the most relevant chunks for my given question. So their embeddings are not stated here. And I was wondering where the embeddings went. Turns out in this Stack Overflow, as you can see, Chroma DB, just to optimize retrieval, it has the embeddings, but it does not show you so that it can save memory and you can retrieve faster. So although it's not visible, it's there. There is a parameter you can pass to display it, but we will not go over that, right? But nonetheless, the document is what we are really interested in. The embedding was only useful for fetching relevant results.
So these are the top three documents. I think this must be document 00, right? This must be chunk 00. This must be chunk 1, 2. Here is chunk 1, 2. And here is chunk 0, 1. This is chunk 0, 1. So these are the three chunks. And what I want to do is now I want to create a new prompt where I will have the question followed by the three chunks, which will provide context to my large language model. So from the perspective of my large language model, the new prompt, the augmented prompt that I will pass will have not just the question, but also these three chunks that provide context about the question. So let me do some prompt engineering. Again, the kind of prompt engineering you can do here is limitless. That itself can be another masterclass or workshop separately. Every component that we've studied so far deserves its own workshop for optimization, etc. For now, to keep things concise, I'm going to create a very simple prompt. Without going into much of the details about what's happening here, I already described the code here orally, so I'm not going to go into much detail here. I'm going to show you the prompt though. So the new augmented prompt that I have created using this code is, how do I manage my saved address? That is the original question we intend to ask. And then we say, use the following context and number one, and then we've attached this context. This is the first context. And yeah, this is the first context. And then we say number two, and this is the second context. And this, when this new prompt, now earlier the prompt only had this question. Now the augmented prompt has not just the question, but also this context. And this new prompt is what we will give to the large language model. So again, as before, we will query the large language model. We will say get Olama response, augmented query, and query model, of course, which is Llama 3, and we will get a much better response, I hope. All right, so now it did not give a huge response. Its response is quite concise. It says, according to the context, you can manage your safe address by going to account settings, your address. From there, you can add new address, update existing address, or delete addresses that are no longer needed. Awesome. Let me quickly go to, is there a way to check if this is the correct response or not? So this is actually the correct response. This response was given in one of the documents that we passed. I can maybe quickly do a Control F and show you. Right. So you remember we did this, we created this augmented query, right? In the augmented query, we passed this context, use the following context. In the context, as you can see, we are passing this chunk, right? This first chunk. In this chunk, we have, how do I manage my saved address? And here, literally, we have the correct, way of correct way of saving the address. Or wait, was that the original question? How do I manage my saved address? What does it say here? Yeah, so basically using this information that it has here in the chunk, provide the correct response. I'm unable to find that PDF document where I could show you that this is indeed the correct response, but you will have to take my word for it, and that this response is actually grounded in reality and it's not hallucinating. Now you may have questions like, if you're creating a chatbot, this was only a one-to-one API response, but what if you're creating a chatbot? Again, that is another masterclass in itself. And if you're creating a chatbot, you cannot really respond to the customer by saying, according to the context. You cannot really use language like this because in the eyes of the customer, there is no context, right? The customer was only interested in asking this question. Everything else was provided by you programmatically behind the hood, right? And this is not something that you want to respond with. So how do you tune your large language model without using such language to respond in such a way that it makes sense to the user? All of that requires awesome, smart prompt engineering. And prompt engineering, is another itself, which, we can go into another day. So this was it from my end for this workshop for how to construct a RAG from scratch for a domain such as customer support. We took the example of, being a data scientist at Amazon. We started with one query. We saw how to create a vector database, which is essentially the RAG pipeline. We saw how we can query the vector database to retrieve context, and how we can combine the query and context to create another new query called augmented query, and how that augmented query now supplies more information to the large language model, and that more information helps respond with facts and less hallucination. So yeah, that was it from my end. We will be sharing this notebook for your reference so that you guys can try it out, test it out, and see how things are. And I'm about to stop sharing. Yep, I'm open to any questions if you guys have. I know it did not work for some of you guys. I can see it in the chat section, but I'm happy to take any questions if you guys have. Mary, if you could help me shortlist any questions that candidates put in the chat section, that would be great.
Let's see. So, do you guys have any questions? Were you able to follow along? It looks like Dhruvi has a question. How do we decide on chunk size?
So how do we decide on chunk size? It's basically trial and error. Your chunking strategy determines the kind of chunks that you retrieve. If your chunk size is too small, then you're probably going to lose information. If it's too large, then you may be providing unnecessary information to your large language model. So the ideal chunk size really depends on trial and error. The chunk size that works for one language model may not work for another language model. So it really depends on trial and error and fine tuning your, parameters. Happy to address any other questions that you guys may have.
Could you recommend a couple project ideas using RAG, perhaps replication of this, but something else? Would be cool.
Could you recommend a couple of project ideas using RAGs, perhaps a replication of this, but something else would be really cool. Customer support is a great application because that's where, chatting is most relevant. But of course, large language models are not limited to chatting. You can use them for, zero-shot reasoning, a zero-shot classification, which basically means, behind the hood, if let's say you don't have data, but you want to, let's say, intent. If you want to know if the intent is positive or not, right? You use that question and you can prompt your large language model to tell if it's positive or negative. Now, this is a trivial example, but there will be so many cases wherein for the large language model to make a decision, it will need more context. And you can supply that context by creating RAG. So it does not have to be a chatbot like the one I demonstrated today, but you can find RAG application in marketing. You can find it in, e-commerce. You can find it in even finance and health domains. So yeah, that would also use LangChain for splitting, chunking, etc. Example, the semantic chunking. Good point. So earlier Dhruvi asked the chunk size, right? So there are different chunking strategies also, such as semantic chunking, right? We could use a number of techniques, Bora, semantic chunking, fixed length chunking, or summarizing and then chunking, etc. This would really depend on trial and error. Whether you want to use LangChain or you want to do it manually, that is again a personal choice. While LangChain is great, I really like the kind of work that the LangChain team has done. I sometimes think that it makes more sense to just do things from scratch. Sometimes including libraries such as LangChain is an unnecessary wrapper around the code. you can writing code from scratch will take fewer lines than writing it using LangChain sometimes. So it really depends on your need. So if you want to use LangChain, if you want to use semantic chunking, it really depends on the application and experimenting. So Malik has asked, how do we build such pipeline for PDF with images? For example, a tutorial PDF can have text plus image to describe. Excellent. So like I mentioned, today's workshop was more about extracting text from PDF documents, but you could have images as well, right? You could also have tables. In fact, one of the projects that I was working on at Columbia was extracting images and tables for RAG applications, which is interesting, but comes with its own challenges. So how do you build such pipelines? To extract tables or images from PDF documents, you would need a mechanism to do that. For example, the mechanism we was object detection. So you take document images, which are images instead of PDFs, and you detect where the image or table might be present. Once you detect it, you can use those bounding boxes to crop that section. Once you crop that section, again, you have to perform OCR on that section to extract the text present in the image or the table. Or you can partition that image into smaller images and then put that into something like ChartGemma. ChartGemma is a large language model developed specifically for this purpose. So you can use something like that to, build or something like that to extract information present in charts. And that information can be used as context for a large language model. So you can look up ChartGemma for that use case, Malik. There are a lot more questions coming up.
Yeah, let's
Uh,
take the last two questions, Akshit.
okay. So which one would you like me to answer, Mary?
Let's see. Is there a way, Ijoma is asking, is there a way to design the database indexing so that it returns the exact document titles that it returns responses from?
Is there a way to index so that it returns the exact document titles that it returns responses from? Well, that is certainly possible. You could do like a keyword search instead of using embeddings. So I think I forgot to mention, but it's like these days, people are crazy about using embeddings to find chunks or to find documents that are similar to my question. One way of finding documents that are similar to my question is by embedding them. But another way is just, a keyword search. That also is really helpful. Or how Google PageRank works. You go to Google, you type something, and the PageRank algorithm, it finds relevant web pages for you, right? So any mechanism of identifying relevant text should work. It's completely okay. So I think for your application, keyword search is the most straightforward. It will return the exact document title that the document had. So I think that answers this question. We'll take one more question. How would you evaluate a RAG application? How could I prove that the application increases productivity? How would you evaluate a RAG application? So there's something called RAGAS framework, and there are other, benchmarks to evaluate RAG. We will not go into that because that again is another workshop in itself, understanding how faithfulness works, answer correctness works, etc. But you can look it up. RAGAS framework is what it's called. And how could I prove that the application increases productivity or other success metrics? Excellent. So any undertaking by a company is measured using, whether it brings in money or whether it helps us save money, right? If you've built a RAG application and you do some sort of A/B test to see if introducing a RAG is helping you or not, then you can identify if it's even worth building a RAG. In many applications, you may not even need a RAG, right? So whether it's increasing productivity or not, you will need to really sit down and conduct an A/B test and see if it's really bringing in the money or helping you save money. Okay. I think somebody shared the link to Ragas. That's awesome. So we are, I think, on top of the hour. We could take another question if you think we still have time, Mary, or we might as well wrap up.
Yeah, it's been 90 minutes. I think you did an excellent job explaining everything from end to end. And I think many of us got lots to experiment with after after this workshop. I hope you guys take your time. We're going to be sending the complete version as well if you weren't able to catch up today. And I know some of you had issues with connecting to your documents, but try again. Sometimes it just can be a simple bug. Just take your time and experiment. And if you want to connect with Akshat, please go to LinkedIn. I think Akshat just shared his LinkedIn. And he has his own Top Made mentorship. He's an active mentor. And if you have any questions, feel free to contact him. He's also on our platform at Break Into Data. And if you guys want to have these type of workshops on a weekly basis, consider joining Break Into Data Pro community. We are always experimenting with new AI engineering repos, tools, libraries, and creating hands-on projects like these. And yeah, we would love to have Akshat over again. Let us know if you can do it. I know you're busy. I think you're starting your new position, so congratulations on that.
Yep,
But
thank you so much.
yeah, if you have any questions, feel free to reach me or Akshit. And again, remember about the thing that I said about AI engineering program that we're building. If you want to be part of it, if you want to share what you want to learn so that we create a customized roadmap for you, please reach out to me either on LinkedIn or at Break Into Data Pro community chat. But yeah, that was great. What'd you guys think about today? Give us thumbs up and we'll send the recording and everything else. Great. I see the thumbs up. I see the hearts. I see everyone. Awesome. Thank you so much, Akshay. That was so clean, perfect, easy to follow. I think you had a knack for this. I honestly enjoyed listening from the very beginning till the very end. I think you're able to keep everyone's attention. So thank you for doing that and would love to have you again soon.
Yep, I would love to maybe have another workshop sometime. It was a pleasure speaking to you guys. Have a great day. See you.
Great.
Bye-bye.
Awesome. Bye-bye, guys.
Thank you. Bye.